What's up, everybody? I'm Matt Gary, and in this episode of Coding with the Fours, we're going to go over the Liskov Substitution Principle. We'll find out what it is and how to actually implement it in both Apex and JavaScript. Alright guys, welcome to the fourth episode of the Solid Design Principles tutorial series that I'm putting together. In this episode, we are going to go over the Liskov Substitution Principle, what it is, why it's important, and we're going to go over an example of how to implement it in both Apex and in JavaScript. So when you're out there writing code, you actually know how to use it and practice. So let's get to it. First things first, let's find out what the Liskov Substitution Principle is. I'm going to start this by reading the original definition of the principle written by Barbara Liskov herself back in 1988. And then I'm going to go into a simpler explanation of that definition. Now, when I read this definition, don't bail on me. If you hate it so much, just skip the next 5 seconds, 10, 15 seconds. It's going to be a little confusing, but I promise I'm going to break it down and make it a lot easier to understand. So, all right, let's get to it. The Liskov Substitution Principle, as Barbara Liskov herself wrote it back in 1988, is defined as the following. What is wanted here is something like the following substitution property. If for each object O1 of type S, there is an object O2 of type T, such that for all programs P defined in terms of T, the behavior of P is unchanged when O1 is substituted for O2, then S is a subtype of T. Now that definition is confusing. The principle itself is a great principle, but because the definition is confusing, it's hard for the average person to pick it up and actually use it, right? So let's figure out what it's trying to get across to us. Historically, the Liskov Substitution Principle was very focused on inheritance, right? It's the primary thought around it was, if I extend another class in my system for this task creator class, then any of the methods within this class here, I should be able to use within this task creator service without causing a problem, right? Or something along those lines. So if I was extending this fflib_any_order class, which is part of the Apex common library, or actually I think this is part of the Apex mocks library, I should be able to use this verify method and any other overridable method within it without causing a problem, right? So basically I'm saying the task creator service here should be able to use any method within this class that it extends without causing a problem. You know, it doesn't need to throw an error if it uses that method, things along those lines. Now, over time, this principle has kind of expanded beyond its original focus, which was, if I'm a subclass of a superclass, I should be able to use any of this superclass's overridable methods without there being a problem, right? So whether I'm task creator service extending fflib_any_order, or maybe if I was this clone record service class and I extended fflib_any_order, I, as a subclass of this superclass, should be able to use any of its methods without any problems coming up, right? And that should be true now and in the future for anything else that I think I want to have extend this fflib_any_order class. Now, these days, it's kind of, the way it should be used is really as a guiding principle for substitution in your architecture in general, right? Not just with superclasses, but also with interfaces, right? If I want to implement an interface, so if I wanted, this clone record service to implement the clone interface, then I need to be sure that clone record service could implement both of these methods without there being a problem, right? That clone related records wouldn't require me to throw an error or have any problems, and same thing for clone record. So it should be used for interfaces as well, this guiding principle. And I'll show you here why it's a big deal in just a second. But also, it should be expanded past just interfaces and, inheritance from superclasses as well. And, a good example that Robert Martin uses in his book, Clean Architecture, is, what if you have a taxi dispatching service? Again, this is his example, and it's not one that's particularly relevant. Well, maybe it could be for some Salesforce orgs, but say you have a taxi dispatching service. Maybe it's Uber or Lyft or who knows, right? And that taxi dispatching service has calls out to a whole bunch of different taxi services APIs. Ideally, every single one of those APIs would have been built with the same kind of URIs that I can call out to, right? So if I wanted to say, this is your destination, this is the pickup address, this is your pickup time, I wouldn't have to, basically build new URLs for every single taxi service that I was calling out to, right? There would just be kind of an interface that guides the creation of each one of those APIs that I call out to, so that whoever or whatever is calling out to those many potential companies that I'm dispatching taxis to, or taxis from, rather, they're all abiding by the same guidelines, which makes it so that if I'm creating code to actually dispatch those taxis, it makes it way easier, right? I'm not having to write a whole bunch of specialized code for each integration. I'm basically just saying, all right, every single one of these integrations is gonna, every single one of these APIs for each taxi service that I'm integrating with is gonna abide by this kind of REST interface documentation that I'm giving them. And if they do, then it means that all the code that interfaces with those places is much easier, right? So it's not just like within your code base itself, or even really something that you can predefine necessarily with like a subclass, or a superclass or an interface, but it's guiding rules for substitution in general. When you see an opportunity for substitution to take place, you want to make sure that you design your architecture in a way that allows you to actually use substitution easily. Now, I realize everything that I just said still might sound a little confusing. You might still be confused, and that's okay. Stick with me when we get to the Apex and JavaScript examples. We're going to go over it in a little more detail and a little simpler terms, and I think it's going to be really easy for you to pick up and grasp and to run with. Now, before we get into that, before we get into those examples, let me just quickly explain why the principle is so useful when you use it. We've actually used the Liskov Substitution Principle in both of the previous videos, the open-close principle video and the single responsibility principle video. And if you were, following along, you can kind of maybe already see why it's such a useful principle in practice. Now, in the first episode, we took a look at the single responsibility principle, and we broke up this calculator combined service class into a bunch of classes that deal with only the single responsibility of calculating opportunities for a CTO or calculating them for a manager or a sales associate, right? Which made this behemoth of a class, well, I mean, I realize this is small, but it could turn into a behemoth of a class, become really, it broke it down into really simple classes, right? And to achieve that, you can see that every single one of these classes, op calculator, service sales associate, managers, CTO, they all implement this op calculator interface. And all of them are able to successfully implement this calculate ops method, right? So because each one of these classes that implement this interface are able to successfully implement calculate ops, the method within that interface, without throwing an error or having any problems, we're abiding by the Liskov Substitution Principle, right? And because we do abide by the Liskov Substitution Principle, we're able to do this wonderful and very cool thing, in my opinion, where we're basically initializing at runtime one of those classes, op calculator service, sales associate, or managers, as the type op calculator interface and calling the calculate ops method. Now, if any one of these classes failed to abide by the Liskov substitution principle and was not able to actually implement this method without causing an error or having a problem, well, then we couldn't do this, right? This wouldn't work because we'd call this method and an error would be thrown and there'd be a huge problem on our hands. So you can see how by abiding by that structure and making sure that all your subclasses truly can implement things, you kind of have this flexibility to now implement or initialize them by their interface and just have a considerably simplified code, right? And if you don't know what interfaces are, or this is all making you really uncomfortable right now, talking about interfaces and maybe looking at this thing that is using the factory pattern or whatever else, please check out my other videos on the factory pattern and interfaces where I go over this all in detail and then come back to this one. And I promise what I just said is going to make a whole lot of sense. But if you don't know what interfaces are, you don't know what the factory pattern is, you don't know a handful of these concepts, it might be a little bit confusing. So I've got links in the description for you to go check out those videos if you're lost right now because of these things. And it'll clear them all up. I hope, anyway. Okay, so as you can see, pretty cool right here, right? And it can really drastically reduce your code. It can make it so that you never have to change code. If if you needed to create another one of these op calculator service for I don't know who else, the CFO maybe or something, then you could just have it implement this op calculator interface, and as long as it abided by the Liskov substitution principle, you could just call this calculate ops method on it and you'd be good to go, right? So very little work involved if you can actually, basically kind of template out your code like this and make sure that anything that, says, hey, I am of type op calculator interface, I can successfully use this calculate ops method, well then, you got a lot of power in that in the long run. As long as you stick to it, right? All right, cool. So we've gone over what the Liskov substitution principle is, why it's potentially so useful. And now let's go over an Apex example. So I've got an example somewhere. Let's see where it went to. Maybe I closed it. I wouldn't be surprised. It is this task service interface, one of them, task creator interface. There it is. So let's close all this other junk and just focus on this task creator interface. And we've also got, oh, that was actually what I wanted, this task creator service, which shouldn't extend fflib any order any longer. Now, with this task creator interface, first things first, this is a bad example. And what we're going to do is clean up this example so that it actually works right. But first, I want to explain why this is a bad example, and then we'll figure out how we can fix it to make it so that anything that implemented this task creator interface would work just fine, right? So, say we're over here in task creator service, right? And we want to actually call task creator interface. Well, first things first, we don't have a class. So let's create another class that actually implements the task creator interface. And we'll just call this contact task service, right? And we want contact task service to implement the task creator interface. Cool. Now let's grab these methods, bring them on over. Might actually, there we go. Nope, I'm pressing the wrong buttons, which is great. So we've implemented both of these methods, and I think we can probably immediately see we might have a little bit of a problem. This is a contact task service, and we are potentially creating tasks for an opportunity on here, right? So we'd have to pass it an opportunity and a what ID, and then down here we have something that's more relevant to contact, which is the create task for contact, where we send a what ID and a contact. Well, that makes sense, right? We'd love to implement this method, but this one, you know, maybe we just want to say like return null, or we could say, you know, throw custom exception, whatever that ends up being. You know, we'd want to throw an exception or something, right? Because we're saying, we can't actually create a task for an opportunity because that really isn't relevant to our contact task service. So one way or another, whether you're throwing an exception because it's on this and you don't want it to actually be used on this class, or you're just returning null, which is probably worse, in my opinion, than throwing an actual exception. Now we're immediately not using the Liskov substitution principle, because eventually what I want to do is, you know, I'll create another one. We'll just, for this, we'll say system debug created a contact task. Okay, actually, real quick, before we move on, this is definitely going to error out. So let me just create a new exception class. We'll just say task exception. Gotta declare it as a class though, that's important. Public task exception extends exception, and that's really all I need. And then up here I can say throw new task exception task creation problem contact service. And then the next thing that I'll do, so that we can move along and see exactly why this becomes a problem, is we'll create an opportunity task service. And now that I've spelled task wrong there, I will have it implement the task creator interface. And we'll basically just, you know, to keep this simple, bring this code over here. And we'll just switch this up a little bit. Obviously for the opportunity one, I don't want to create a task on contact, so we'll say this is a problem for the opportunity service. And we will say that we created an opportunity task otherwise, right? Now, I've got these two classes, opportunity task service and the contact task service. And now I want to kind of create this kind of intermediary that actually calls one of these services for me, right? Well, I can do that. I can basically do something along the lines that we saw before, where we have like a map of object or S-object type to type, and we'll call it object type to implementation or something, and then we'll say new map S-object type S-object type. Oh boy. S-object type. Goodness, there we go. And type. And then we'll actually make our mapping here. So we'll say, you know, if we have an opportunity S-object type, then we want to map to the opportunity task service class. And alternatively, if we have a contact, I don't even think I have health cloud in my org, contact S-object type, then we want to initialize the contact task service class, right? So this is much like the example that we saw just a little bit ago when we were going over the why portion of why the Liskov substitution principle is so useful. So at this point, basically what we'll do is we'll say something along the lines of task creator interface, tasks creator equals object type to implementation dot get record dot S-object type get S-object type, and I will need to cast this again, something that we go over in prior videos in this series and in the interface videos if you've not checked those out. And it's complaining because I haven't made this static. Okay, so now we're kind of using the factory pattern to dynamically, you know, initialize one of these services. And actually, I'm going to just make this a little, well, you know what, it's fine. So we've got this set up, and we want to say task creator dot create opportunity task, and for now, to make this really, really simple, I'm going to pass in null. And we also want to do task creator dot create opportunity, right? And again, we can just pass in null again to keep this easy. I'm actually going to make this even easier on myself here so that we don't spend a lot of time creating S-object records. Let's just go on ahead and say string, and if I pass in the string op, I get the opportunity class, and otherwise if I pass in the string contact, I get the contact task service. And I'm just going to pass this in as a string, object type, and do that instead. That way I can do this really quick and I don't spend a lot of time creating records for no reason. I've also got to remember to put the new instance over here, or we're going to have problems, which is why I cut this video, because I didn't remember to do that. All right, so now that we've got this set up, let's go on ahead, open up our Apex Anonymous window, and let's just call this task creator service, create task, and pass it contact and see what happens, right? So I've got that set up in here. If you can't see it, there it is right here. And we're going to run this code now. And I have apparently failed to save this, so that's important too. And now if you see, right, there was a task exception. There was a problem, task creation problem, contact service, right? And that's because we were in that contact task service, and we can't actually create that task for an opportunity on contact. There just is no way for us to do it in this service. And that's detrimental because now we can't have this kind of abstract task creator service that, you know, forces us to abide by this contract and you know, create tasks in a specific way. If we wanted it to work, right, and we'd see, you know, we'd see this same problem where this custom task exception gets thrown. If we send an op, it's going to say, hi, hey, there's a task creation problem in the opportunity service, right, which you can maybe read right here. And that's detrimental, right? So how would we resolve this if we don't, you know, have our classes abide by the the Liskov Substitution Principle? Well, if we didn't go back and fix our classes and fix our interface in general here and have them actually abide by things, then we'd have to do some really unfortunate stuff, in my opinion. You'd then have to say, you know, if object type equals contact, then you run this one, else you run this one, and, you know, this could go on and on, right? You know, you could have 30 different objects that you create tasks for in your system. And now you've kind of partially defeated the purpose of all of these solid design principles that we're trying to figure out together. And now you've made this complicated because you didn't create your interface in a way that allows its implementers to use all of its methods, right? So now I've got this task creator service that has this if statement that says if object type of contact, then I do the contact create task, otherwise I do opportunity create task, and you know, that's not ideal. It fixes the problem, right? Now that I've done that, I don't get any errors. I just get my one debug where I created an opportunity task down here. But, you know, this is kind of sad. And you can see it can create some pretty challenging problems if you expanded this class a whole bunch. Now, if we just fixed this interface and made it so that our subtypes, or rather our implementing classes, could use all of the interface methods, well, then we'd be in a little better shape, right? So let's give that a shot. Let's just create another interface, and we'll call it task creator LSP interface, because it's LSP is short for Liskov Substitution Principle. And in this one, instead of having one that creates tasks for opportunities and one that creates tasks for contact, we're just going to say void create tasks, right? A lot more generic. We can pass it a what ID, ID, what ID, and we could pass it an S-object record. In fact, we probably don't even want to pass it the what ID, because we can probably get that from whatever S-object record we pass in, right? So we've got this new interface, task creator LSP interface, that just has this create task, very generic method that our other task services could potentially leverage. So now we come over here to opportunity task service and have it implement that new interface. Get rid of this junk here. And we could then say, create tasks. And we'll say, system creating op tasks. And then I'm just going to copy this. We're going to go over to the contact task service, have it also implement task creator LSP interface, get rid of all this junk, and have it say creating contact task records, right? Which is great. Now, both of our services, whether it's an opportunity or a contact, can implement the same method, and there's no problem with them implementing every method in this interface, right? We could do that because this is generic, right? We're creating tasks for just an S-object record in general. And then so we can go back over here to our task creator service, our kind of more abstract thing that maybe our controllers or a batch class would call. And we will instead initialize that task creator LSP interface. And we now just do task creator dot create tasks. And of course, I'm just again going to pass null so that I don't actually have to create a record and waste your time doing that. And let's just save all this stuff and see how it runs, right? So now, regardless of whether I pass op, in which I get creating op tasks, or if I pass contact, there are no errors thrown. I get a different thing for each one, and we're abiding by the Liskov Substitution Principle. So I think you can see, I mean, I realize this is a somewhat simple example and maybe a bit obvious, but you can see that just by changing the way that this interface works, instead of having methods that are so specific in the interface, and then rather creating ones that are more abstract, that are easier for each implementer to actually use or be able to use, we've created this wonderfully abstract service here that is able to basically take our interface, or I kind of like to view it as like a template for what we can do for any task creator service in existence, whether it's here now or in the future, and create tasks for it, right? And there could be other methods like cloning tasks or deleting tasks, or who knows, right? And now you can use those methods without an error being thrown or a problem or whatever else. So pretty cool stuff. All right, so we've done an example of this in Apex. Let's switch over to the JavaScript side and see how this works over there as well. All right, so let's create a new Lightning web component and figure out how we might make this work. So we'll create a new Lightning web component. I'll just call it, who knows, task creator LWC, and hit OK. And like we talked about in the last couple of videos and other videos that I've done, I think, JavaScript is not a typed language like Apex, right? And what that means is that you can't use interfaces. You can't, have something implement an interface, and you don't if you're creating a variable, you don't say string person name equals hi or whatever, you know. Oh boy. Okay. Instead, you would just say person name equals hi. Like that. Now, Apex would hate that, and it would be super upset with you for doing that. But in JavaScript, if you did the reverse, you know, and I said string person equals hi, it'd be very confused. As you can see, there's already a little error here. It's like, what are you talking about? This means nothing to me. Get it out of my face. And if I did that, it's perfectly fine. So it's not a typed language, which means that you can't have interfaces. That said, you can extend things. You can extend classes, much like we talked about very early on in this video, so that you can have superclasses and subclasses and do the whole idea of inheritance. Now, before I get into this example, I just want to state, I don't know that I would often suggest inheritance. Sometimes it is a good path to take, but you have to really know when to use it and when not to use it. I'm not going to go over all that in this video, but just know that if you do use an extension instead of kind of a loosely typed interface that I'm going to go over in a second too, that you've got to be certain that it's the best choice. Don't try to use don't try to use a superclass and use inheritance to replace an interface. It's probably not a smart move, I guess is what I'm going to say. Now, if you want to actually use inheritance, which is a little bit different, then you know, that's a different topic altogether. But please, lots of people try to use superclasses and inheritance to replace interfaces, and that's just, you just probably shouldn't. So with that said, let's go over how you would potentially do this in JavaScript, right? So if I wanted to use inheritance to kind of make things abide by something, we'd create another JavaScript file. We'd maybe make it task creator, and we give it a couple methods. Maybe we have create tasks, and it outputs, you know, something tasks created. You know, in a real scenario, it'd actually probably create tasks, obviously. And then we'd create some other JavaScript classes that extend that. So maybe we say contact task creator, and it would extend the task creator class that we just created. So it would inherently have access to that create tasks method, and if we wanted to override this create task method, then we'd just say create tasks, and you'd call super.createTasks and then do, you know, whatever it is you want to do after that, right? Whether it was completely undo whatever createTasks did, which hopefully you didn't, because then you'd pretty much be violating the principle again. But you'd, you know, then do whatever you wanted to do. So you'd say something like console log creating tasks for contacts, right? And, you know, I don't know what this would do. Maybe it could return something that was useful to you, and you actually created the tasks in here. But I think you get the general picture, right? You've now got this contact task creator that extends the more generic task creator interface, and it calls to its superclass to create tasks in this method, and then it does its own unique thing for contacts afterwards, right? And you do the same kind of thing for opportunity or case or whatever else you're creating tasks for in your JavaScript. And you'd have them all extend task creator, and you'd want to make sure, just like before, that each one of them could actually use task creator as a superclass, right? Now, you might be thinking, all right, that's cool, but what if I want to use an interface? What if I want to do the same thing we just did in JavaScript, in Apex, but in JavaScript? How would I actually do an interface and abide by the Liskov Substitution Principle, right? The answer to that isn't as simple. Basically, you wouldn't extend anything, right? And you just kind of have this loosely typed contract. Every single one of your new contact task creators, so if we did another one, we'd say opportunity task creator, and we just have to make sure each time that we implement this create tasks method, and that every single one of these could implement the create tasks method, right? Now you can't say anything like implements in JavaScript again. It can't implement something, even though it liked that keyword for some reason. Unless you're using TypeScript, you can't implement an interface, and you can't force a JavaScript class to abide by any method contracts within it, right? Even technically speaking, if I was still extending the task creator in a superclass here, I wouldn't have to use, there's nothing forcing me to use anything in it, right? Or set up any methods or do anything like that. So you really have to basically make sure that you document, this create tasks thing, this LWC that I'm creating, every single time that you create a new class for cases or, maybe campaign members or whatever else, to make sure that you use this same method in each one. And I'm not gonna build all this out again, and mostly because in previous videos in this tutorial series, we've actually built this out. So let me just kind of go over to one that we've already built. If you haven't seen the single responsibility principle tutorial, we actually build this whole thing out together, step by step. But we use the concept of interfaces in this example. But as you can see here in this JavaScript example, we have this ops service manager, calculate ops. We have ops service CTO, which also has the method calculate ops. And I think that's it. But then we also have this ops service that says, if we pass in a user type of CTO, then we want to initialize a new JavaScript class of ops service CTO, this guy right here. Otherwise, if it's a manager, we want to do a new manager, this guy right here. And then we want to send that in to this factory class that we have called ops service factory. And we want to call the calculate ops method in the ops service factory. And as you can see, what this ops service factory class takes in is a class type. And it assumes that that class type has a calculate ops method that it is okay to call, right? So what you're doing here is really basically forcing your JavaScript classes to abide by these invisible interfaces, ones that don't really exist. And you just have to document them in your code it's probably best documented in your factory class here. If you want to create a new class, it needs to implement the calculate ops method, or be able to implement the calculate ops method. Otherwise, it should not be used in this factory, or something along those lines. So you can see that because this example that we did, again, in great depth in the single responsibility principle video, because these JavaScript classes abide by this kind of invisible contract, we're able to implement still the Liskov substitution principle and have this wonderful thing where, despite there being nothing forcing us to abide by anything, we are able to substitute out class types as we want to basically create these really abstract, nicely formatted pieces of code, right? And that's the whole idea, is whether you can force something to follow a contract, or whether you have to set out and create kind of like an abstract contract that you and another system and another system and another system all abide by. You're able to substitute out one class for another, and it doesn't matter. You can do that, and then all of a sudden your code base has so much more flexibility, and you can expand on it so much more than if, JavaScript class A had a different contract than B. Maybe for some reason Ops Service Manager had the name calculate, where am I? Yeah, so maybe it said calculate ops calc or something for some reason. I don't know why, but we didn't abide by our template or our contract or whatever you want to call it. We couldn't substitute it in here now, right? We couldn't send that in. It would say, there's no method, and it just fail and crash and burn. So I hope in the last however long this has been, I've gotten through the point that the Liskov substitution principle is about much more than, I'd say, the average website or tutorial or whatever else feeds to you. It's about being able to kind of genericize similar things, whether they're on your system and another system, or whether they're just in a couple Apex classes or whatever else. It's about, just thinking about how can I make my code simpler? How can I make it so that I can, take two extremely similar processes and merge them, have them abide by some contract that I've either made up out of thin air or I'm using an interface for or whatever else, and be able to substitute them, in and out of your code, right? Hopefully that makes sense. This is kind of a tough one to explain without having multiple systems up and really getting wild with it, but hopefully that all is understandable. It comes across. I think if you take what I just talked about and you go back and you rewatch this JavaScript portion of the single responsibility principle episode that I did, it'll really click really well. But anyway, hopefully that helps kind of give you a base understanding of the Liskov substitution principle. Hopefully it gives you an understanding that it shouldn't just be a principle that is taken into consideration for extending classes or inheritance, but it's something that is broader and should be taken into consideration when designing things like APIs across multiple systems, or when it's designing things for non-typed languages or whatever else, right? It's just this way to make things simpler, more abstract and understandable just in general across your organization. Yeah, all right. I think I've talked plenty. If you like this video, make sure to subscribe, hit the actual like button, and the bell if you want to be updated on the next video that comes out. And yeah, guys, thanks for watching, and I will see you in the next episode.